Hi guys, welcome back. It's Professor Hank, and it's time for another Kotlin tutorial video. And in this video, we're going to go over the basic decision structure, which is the if statement. So we'll look at a couple of examples of that and how you can use it and how we can add basic decisions to our Kotlin programs. So let's go ahead and get started. So we've got a couple of different fundamental options here when it comes to if statements. Okay, we've got the basic old if, in which case, you're going to have this if statement, you're going to have this test expression. And if that test expression evaluates to true, then the statement or statements that are attached to that if statement will be executed. Otherwise, they won't. So it's either, it's kind of like a do or do not kind of thing. Okay, so you've got that. And then another option is, if else. Right. So what you can do is you can have an if with a test expression, and if that test expression evaluates to true, then that block of statements, that statement or statements will execute. Otherwise, else, there'll be a statement or a block of statements that executes otherwise. So you can think of a basic if as, if something's true, then you'll do A or you won't do A. Do A or skip A. If else is do A or do B. All right, so let's take a look at an example of both of those. An example of these things working. So I've got my Kotlin video going, or a Kotlin project already started here. And we'll go ahead and get started. And what we're going to have to do first is we're going to have to make that main function that all Kotlin programs have to have. So we'll start off by having keyword fun, and then we'll do main, and then we'll be ready to get started, right? So we've got a main function, and then we'll need to import Java util.scanner, import java.util.scanner. Okay, and what that's going to allow us to do is to ask the user for some input, and we'll be able to store that input. Got a previous video on how to get input from the user you can check out in the playlist if you like. So we're going to create a variable S for scanner, and then we'll assign it a scanner object, and then we have to specify where stuff is coming from, and that's going to be coming from system.in. Okay. All right, so the basic structure of an if statement is if test. Okay, then do stuff. Now, the question becomes, how do you create the test? Well, we have to introduce some operators here. We have to introduce relational operators. Okay, so relational operators. So these guys are going to evaluate to true or false, and these are going to look really familiar. If you remember back from arithmetic, or if you programmed in any other C-like language at all, then you're going to remember these guys: less than, greater than, less than or equal to, greater than or equal to, equals to, and not equals to. So you can create the syntax for this is, if you want to check to see if X is less than Y, for example, that's a test. So that will evaluate to either true or false. Or if you want to see if X is not equal to Y, right? That's going to evaluate to true or false. So these are pretty fundamental. So, for example, 5 less than 2, what is that? Well, that is false because 5 is not less than true. What about 5 greater than true? Well, that's true because 5 is bigger than 2. How about 5 greater than or equal to 2? That's true because 5 is either greater than or equal to 2. So that's true. How about 5 less than or equal to 2? That's false because 5 is not less than or equal to 2. What about 5 equal to 2? Well, that's false because 5 is not equal to 2, right? 5 is bigger. And what about 5 not equal to 2? Well, that is true because they're not the same. Another thing, when you look at the greater than or equal to or less than or equal to, you can have something like this: 2 greater than or equal to 2. Well, that's true because 2 is equal to 2. Okay, now 2 greater than 2 is false because 2 isn't bigger than 2, but 2 greater than or equal to 2 is true. Okay, so that's kind of the basics of how those things work. And so we're going to have that test expression, if test do stuff, right? So let's see that in action. Let's see an example of that. So we'll ask the user, let's ask the user, okay, ask the user for an integer. Okay, so we'll just do something like print enter an integer. Okay, and then we'll go ahead and scan it in. So we'll do something like var I equals s dot next int. Okay, so that'll return an integer. And so then we can compare. We'll say, well, if I is equal to 0, for example. If I is equal to 0, then we can print, the numbers are equal to 0. The number is equal to 0, okay? And then after that, we'll say goodbye. Print line goodbye. Okay, so now remember how just a plain old if works. If I enter in 0, well then this will be true because I will contain 0 and 0 is equal to 0. So then we'll see the output here. The number is equal to 0. Otherwise, if it's not, if it's false, then this whole line right here will get skipped over and then we'll see the goodbye. Okay, so let's go ahead and give that a go. I mean, so it really is that simple. There's not really a whole lot there to the if statement. I'll show you another wrinkle or two here, but there's not much to it. So there's our prompt for enter an integer. So we'll type 5 and you'll see that we just see the goodbye because 5 is not equal to 0. Okay, now let's run it again. And this time I'll type 0. Okay, and you can see the number is equal to 0. Okay, now we can do a couple of things here. We can compare a variable versus an integer, sure. But we can also compare two different variables to each other. So I'll ask for another integer. Enter another integer. Okay, and this integer will be, or this variable will be called j. Okay, and so then what we'll do is we'll just compare these two against each other. So we can do something like this. We can say, well, if I is equal to j, then you can say the numbers you entered are the same. The numbers are the same. Okay, but we can also say if I less than j, then we'll print line, the first number is less than the second number. Okay, so we can do something like that. And then finally, we'll check to see if I is greater than j. Okay, and if so, we'll print line, the first number is greater than the second number. Okay, so now when this runs, what you're going to see is one of these options will be true. Okay, now all three will get evaluated here. All three tests are evaluated. Okay, now only one of these is going to be true, logically speaking, right? Because you're either the same, one's less than the other, or one's greater than the other. So there's no other possibility. So let's test it. Okay, so I'll enter the first integer, we'll just say 0. Enter another integer, we'll just say 0. So the only thing we see is the numbers are the same because this evaluates to true, therefore this print statement executes. But this is false, so this gets skipped. And this is false, so this gets skipped. Okay, but goodbye isn't part of any of these if statements, so it's always going to execute. Okay, now let's do this one more time. Let's try a couple more tests, right? I mean, we got three test expressions, right? So to make sure our code works, we should have 3 tests. So let's do 1 and 2. Okay, so now when the first number is 1 and the second number is 2, is I equal to j, is 1 equal to 2? No, so this gets skipped. Is 1 less than 2? Yes, that's true. So then we see this. The first number is less than the second number. Is 1 greater than 2? No. So this gets skipped, and we see the goodbye. Okay? And one more test, because we got to make sure that all of our test expressions work, right? You want to test thoroughly, and you want to make sure that you don't miss anything. So the first integer is going to be 5, and then the second integer will be 2. So what are we going to see? The numbers are the same? No, because they're not. First number is less than the second number? No, because 5 is not less than 2. This is the only true one right here, okay? So you can do that, but you can also use a block, right? So you can do something like this, okay? If you put these in a block, you know, you can leave it just like that, where we only have the one statement, but you can also have multiple statements in here, right? So you can do something like print line surprise, right? So you can have as many statements as you want in the block. Now this entire block here is contingent on this test. So all the statements in here, no matter what they are, will execute if both of these are the same. So this is very similar. Like I said, this is very similar to what you see in other C-like languages. So not a whole lot new here. Okay, so when I say 5 and 5 as the inputs, well then 5 equals 5, that's true. So this executes, you see the surprise in the output, and then this executes. You see the numbers are the same in the output. Okay, so we can do that. Another thing that we can do is we can use an else. Okay, so far what we've done is we've kind of checked out, you know, if A, then do something. Or if it's true, do A. Otherwise, don't do A, right? So if this is true, do A. Otherwise, don't. Otherwise, skip it. Okay, but what if we want to have the option of doing A or B? Okay, let's see what that would look like. Okay, so let me go ahead and delete this. And then we'll have a test. We'll say if I is less than J, then we'll print line, I is less than J. So I is less than J, okay? And if that's not the case, then we'll say else print line I is not less than J. Okay, so if this first test is true, then this block, which just has one statement in it right now, will execute. Okay, but if it's false, then this will execute. So it's either A or B. It's either or. Okay, so let's see that in action. See what that looks like. Okay, so we're going to enter an integer, and I will say 4, and then another integer 5. So you see 4 is less than 5, right? Because this was true. So A happened, and B did not. Okay. Now, if we cause that first test expression to be false, so do something like this. So let's say we do 8 and 8. Okay. So then this is false. So we skip the A block and we go down to the B block. And so it says it is not less than J, right? So it's A or B. It's A or B. But what if we wanted even more options than that? Okay. We could do something like this. We could say else if, okay, I greater than J. Okay. And if we do that, then we could put inside here, I is greater than. Okay. Now there's three possibilities with two integers, right? They're either the same, or one's either less than the other, or one's greater than the other, or they're the same. Now logically speaking, if one's not bigger and one's not smaller, they must be the same. So then we can say print line is the same as J. Okay, so then what we have here is we've got A, B, or C. Okay, so you can chain these else ifs together. Okay, you can chain them together so that way you have as many options as you want. Now, what if I want to have, like 4 options? Well, we'll see that in a second. So now if we do 4 or 5, what happens? We see 4 is less than 5. Actually, I made a little bit of mistake there. I pushed 4 and 5, and the next int just grabbed them both from the keyboard buffer when I entered them. So let's do that one more time to where it's not as confusing. Okay, so enter an integer 4, enter another integer 5. So you see 4 is less than 5. So this test expression evaluated true, and so the A block executed, and the rest of this stuff got skipped, and we continue on with the rest of the program. Okay, now we can do, or let's test, if the first integer is bigger than the second integer. Okay, when that happens, you can see 5 is greater than 4, so this first test was false. This second test was true, so the A block got skipped, and it's the B block that executed. Okay, and then finally, what happens if we have both numbers being the same? So let's say 5 and 5. Okay, well, the first test is false, so A gets skipped. The second test is false, so B gets skipped. And what's left? The else. So this is kind of like the default option. If it's not less than, if it's not bigger, then it must be this, logically speaking. So we see the C block being executed. Of course, since goodbye is not part of any of those blocks, goodbye is going to get printed no matter what. Okay, so we can chain these things together. Okay, so we can have, let me show you an example here. We'll ask the user for an integer. I mean, we can have as many options as we want, right? So let's write a program that'll convert an integer into a Roman numeral. So you can do something like this. You can say, well, if I is equal to 1, okay, then what we'll do is we'll print line I, right? Because that's 1 in Roman numerals. Okay, then we can also do else if, and you can put that on a separate line if you want, or you can put it here. I think I'm gonna put it on a separate line. I think it looks better. Else if I equals 2, then we will print line 2. Else if I equals 3, then we can print line 3. Okay. Else if I equals 4, then we can print line 4. Okay, and then we can have this little dangling else here that kind of catches everything else. We could print line I don't know how to handle that, right? Or whatever. Okay, so what's going to happen is that we'll go ahead and we'll ask the user for the integer, and then we'll just go through and do comparisons on each of these guys. Okay, and as soon as one of these is true, then we break out of the entire structure and we go down and finish the rest of the program. Okay, and if we get through this guy, this guy, this guy, this guy, get through all 4 of those, then the default is going to be to print I don't know how to handle that. So let's see what that looks like. So we'll test 1 first. Okay, so you can see that this is true, therefore this executes, and then the rest of this stuff gets skipped. Okay, now let's do another example of that. We'll do, I don't know, 3 this time. Okay, so this is false, this is false, this is true. So this executes, and the rest of this stuff gets skipped. One last example. What happens if there are no matches at all? Well, I will show you. So let's say we did 99. I don't know how to handle that. Why? Because this is false, 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 false. So we kick down to the else here. Okay, so now let's take a look at another set of operators, right? So we took a look at these operators here, right? So less than, greater than, etc. Let's now look at the logical operators. Okay, so logical operators. So what do those let us do? Logical operators, right? So these are your and. Okay, I think I can get rid of this stuff here. These are your ands, or, and not. Okay, so in order for an and to be true, both sides have to be true. So you'll have some expression. Okay, so say x greater than y and y less than z, for example. Okay, so in order for this whole thing to evaluate the true, both the left side and the right side have to be true. Okay, so true and true equals true. Everything else is false. Okay, so both sides have to be true in order for the whole thing to be true. Now this is x greater than y, or a less than b. Okay, so true, or I should say false or false equals false. Everything else is true. Okay, so if either x greater than y is true, or a less than b is true, or if both of these are true, then the whole thing is true. The only way this evaluates this whole expression here, this whole test evaluates to false, is if both sides are false. Okay, so what does not do? Not just flips the truth value. So let's say that you have x, right? X greater than y. Okay, so here you're asking, is x greater than y? Okay, that's the question you're asking. Now, if you write not x greater than y, then you're taking the negation. You're saying, is it true that x is not greater than y, right? Or another way of putting it is not x greater than y. Okay, so anything that would make x greater than y true, the not flips it. Okay, so another way of thinking about it is not true equals false, and not false equals true. So it just flips it at that most basic of levels. Okay, so let's take an example, or let's look at an example of that. Okay, so let us say that we wanted to check to see if a number is in a range. Is a number in the range of 0 through 10. Okay, if we wanted to do that, then what we would need is in order for a number to be from 0 through 10, you need a number that is greater than or equal to 0, right? Because we're going from 0 through 10. Okay, but it also has to be the case that that number is less than or equal to 10, right? So we're looking for this. We're looking for this range, 0 through 10. Okay, now take a look at these test expressions. Okay, let us say, and see why you have to use and here. Let us say that I is equal to 22. Okay, well, this first part is true. Okay, 22 is definitely greater than 0. Okay, but 22 is not less than or equal to 10. So if we've got a number line, okay, and this is 0, and this is 10, right? Is 22 greater than 0? Yeah, because 22 is over here, right? It'd be, I don't know, something like that. But is 22 less than 10? No, it's greater than 10. So this would be outside of the range. So in order for a number to be inside the range, it has to be both greater than or equal to 0 and less than or equal to 10. So let us test that. Okay, so we'll have that. We'll say print I is in range. Okay, and it either is or it isn't. It either is or it isn't. Else we'll print line I is not in range. Okay, so let's test that. Okay, and I'll just show you a couple more examples and we will be done. So 5, right? So 5 is greater than or equal to 0 and less than or equal to 10. So you see that 5 is in range. Okay, now what about numbers that are out of range? Well, let's try 22, right? 22 is not in range because even though this is true, this is false. Okay, so since it's true and false is false, the whole thing is false. So we kick down to here. Okay, and then let's do one more test. Let's do -5. Now it's going to be true that -5 is less than or equal to 10, but it is not greater than or equal to 0. So what you're going to have is false and true, which means false. Okay, so enter -5 is not in range. So we kick down to this part right here. Now there's actually 5 total tests we should do if we want to make sure that we're within the range of 0 through 10, right? We tested stuff that's less than 0, right? A number that's less than 0. We've tested stuff where a number is greater than 10, okay? And we've tested something that was in between, but we never tested the endpoints themselves, right? We want to test if a number is in a range from 0 through 10. So we got to test those too to make sure that we got it right. So that just means running it and putting 0 in for one of the tests. 0 is in range because 0 is greater than or equal to 0 and 0 is less than or equal to 10. So that passes. 0 is in range. Okay, now let's try the 10. Okay. And that is in range because 10 is both greater than or equal to 0 and 10 is both less than or equal to 10. Okay. Now that language is really important when we say a range of 0 through 10, right? If this was changed, if it said is a number between 0 and 10, well, now you're not counting these endpoints anymore because you're saying between. So we want a test expression where it'll evaluate the true only if the numbers are between 0 and 10. It's not inclusive with that language. So if 0 is entered by the user, that doesn't count anymore. So we got to get rid of that for 0. Okay. And if the user enters 10, well, that doesn't count anymore because we're in between. So we got to get rid of that. We're looking for any numbers that is in between, right? Previously, we were looking for numbers that included 0 through 10, but now we want to have numbers that are between 0 and 10. So let's test it. Okay, so now if I hit 4, that's in between, so that's in range. Okay, and we already know that negative numbers are out of range and numbers bigger than 10 are out of range. Now what happens if we enter in 0? That should be rejected now, right? Because we want a number in between. Well, 0 is not in between 0 and 10, right? It's 0. Okay, it's from 0 through 10, but it's not between. Okay, and then what about 10 itself? Okay, same deal. Okay, so another thing that we can do is we can have OR. Okay, so let's take a look at OR. Okay, so you can use OR to see if 1 or 2 or the other cases are true or not, right? So what I mean by that is if either test expression is true, then the whole thing is true. Okay, so a good way that you could see, another way to see, or another way you can work with ranges is to see if a number is outside the range. Okay, so let's go back to 0 through 10, right? So 0, 10. Okay, if we want to see if a number is a number outside the range of 0 through 10. Okay, so what is the case, or what can we say for a number that's outside the range of 0 through 10, right? So we can say that if the number is less than 0, it's outside the range, right? Because the range we're talking about here is 0 through 10. So anything that's less than 0 will put us outside the range. Okay, so if it's that, okay, or anything that is bigger than 10, because remember, 0 through 10 is the range, right? So if we want anything outside that range, it's less than 0 or greater than 10 or greater than 10, okay? So we'll then say print line outside, print line I is outside the range. It's kind of just flipping the logic over on its head. Else print line I is inside the range. Okay, so let's test that. Okay, now only one of these has to be true, right? Either the first test expression or the second one. They don't both have to be true. So if we do something like -1, right? -1 is outside the range because this is true, okay, even though this one is false. You only need one or the other to make this entire thing evaluate the true. So now let us test 22, number greater than 10. Okay, now what's going to happen? Well, it's false that 22 is less than 10, but it's true that 22 is greater than 10. So in this case, the second expression here will evaluate to true, and so we'll report that the number is outside the range. Okay, and then the final test, the final one, okay, is we'll see a number inside the range, right? So we want a number that is neither greater than 10 nor less than 0. We want it to be false that the number is less than 0, and we want it to be false that the number is greater than 10. So what number could we use? 0 through 10. So how about 2, right? So is 2 less than 0? False. Is 2 greater than 10? False. Therefore, this entire thing will evaluate to false, and we'll kick down to this else here and print that out, okay? So let's see that play out. 2 is inside the range, okay? If 2 is not less than 0 and 2 is not greater than 10, the only other logical possibility is it's within that range right there, okay? All right, so the last thing I should show you is not, right? So not, and you can combine these two. I mean, you can do, you can chain all these things together, right? You can do something like that, in which case, the and executes first, then the or. That's the order of operations. Not comes first, then and, then or. Okay, and if you have multiples of these, it's evaluated left to right. Okay, so let's see not. Okay, so let's look at another way we can ask, is a number outside the range of 10, right? So if a number is inside the range, we'd say if I is greater than or equal to 0 and I is less than or equal to 10. Okay, so that is inside the range. Okay, but we want to know the opposite, if it's outside the range. So what we can do is we can just say, well, if not. Okay, if it is not the case that I is greater than or equal to 0 and I is less than or equal to 10, then it must be out of range. So it's not this. Okay, if it's not this, right, then what is it? It's either this or this. So then we'll print line outside, else inside. Okay, so let's do it. So let us test 22. Right, so it's outside because 22, so this right here is going to evaluate to false because 22, while it's greater than or equal to 0, it is not less than or equal to 10. So this evaluates to false, but the not flips that to true. Okay, so then we print outside. Okay, now let's take a look. One more example. Let's see, let's put a number in there that's inside the range, right? So let's say 6. Okay, now it says inside. Why? because 6 is greater than or equal to 0, and 6 is less than or equal to 10. So this inner part is true, but the not flips that to false, and so instead of executing this block, we execute that block right there. Okay, so let's do one more thing. Let me show you nested loops. Okay, so nested loops, or not loops, we're doing if statements. Nested if statements. Okay, so what does nested mean? It just means you have one inside the other. So you can do something like this, right? So let's say I ask you to enter your age. Okay? And so you enter your age, and then I say something like, well, if your age is greater than or equal to 21, right? Then I'll say something like, welcome to the bar, right? You're now allowed in the bar. You have to be 21 or older to enter. And then from there, I can say something like, I'll ask you, what should I ask you? I'll ask you if you want a drink. Okay, so we'll say something like print enter 1 if you want a drink. Okay, and then if you do that, then I'll print out print enjoy. Okay, all right, so what's going to happen here? Okay, print enter 1 if you want a drink, and then if your number, okay, we have to read your number again. So s dot next. Okay, we'll do var a for answer equals s dot next int. Okay, and then we'll say, well, if a is equal to 1, right? So if you answered in the affirmative, then we'll print enjoy. Okay, so this only ever can happen if you get past this first test. And if you get past that first test, then you have to get past the second test in order for us to see enjoy. So it gets a bit more complicated when you nest things like this. Okay, so what's my age? Well, now if I enter 18, this is going to evaluate to false, and this entire thing is going to get skipped, and I'm going to say goodbye. Right, so there's your goodbye. Now, if I type in something that, if I type in an age that's 21 or greater, right? So that's going to be causing this first test to evaluate the true. So we're going to enter into that body of that if statement. So then we print welcome to the bar, and then we say enter 1 if you want to drink. Well, now at this point, if I enter 1, this will evaluate the true. We'll see enjoy, and then we'll see goodbye, right? Because this will be true. We'll print this out, then we're out of the structure, we print goodbye. Okay, now what happens if I don't want to drink? Okay, if I don't want to drink, I'm going to put in my age. I'm 27. Maybe I'm the designated driver, so I'll enter anything else other than 1. Okay, so since I didn't enter 1, this evaluates to false, this gets skipped, and then the whole if structure is done, and then we print goodbye. Okay, now we can combine this, all these ideas with else's too. Okay, we can say in here, print line, go away, you are too young, for example. Okay, and then here we can say, else print, I don't know, what should we say if you don't want to drink? Not thirsty, right? We'll say that. Okay, so now it's getting even more complicated. Okay, so let's go ahead and test that. We'll get ourselves, first test, we'll say we're 17. We're only 17, right? So what happens there? This evaluates to false, so its entire block is skipped, and then we print line, go away, you're too young, and then we're done with the entire structure, and then we print line, goodbye, right? So what happens now if we are old enough? Okay, we're inside this block now, right? So now we're going to enter 1 if you want to drink. So let's say that I don't want to drink, also I'll enter 0. So then what's going to happen is this is going to be false, and then we'll kick down to not thirsty. Then this inner if will be done. Right here, this inner if else will be done, and then that'll finish off the entire outer if else. This else will get, this whole part right here will get skipped, and then we'll go down and print line goodbye. Okay, so we'll say 0. Not thirsty, right? We're going to say if it equals 1, that's false. Not thirsty. Then we bust out of this block right here, and this gets skipped since we were in this block in the first place. Okay, so I think that's just about everything that I wanted to show you. So, you know, and you can make this as complex or as simple as you want. Now, one other thing I'll do here is, you know, I'll do something like this, right? And you sometimes will see students do this, and it's gross, is what it is. So don't do it. You can keep on nesting if statements for like ever and a day. You know, so you could do something, you know, like this. You could say, well, if x greater than y, you know, just whatever, just for the purposes of an example. You can keep nesting these if statements inside of each other like this. Okay, this is generally a bad idea. You saw how complicated it got with just the first example. The more you keep nesting like this, the more complex your code gets, the harder it is to read, the easier it is to make mistakes and all of that. So don't do it. Okay, so don't do stuff like this. You know, another example of what not to do. You know, don't do something like this. Okay, and then you have your if statement and all that. Okay, and then inside of here you've got another if statement. Okay, and then inside there you have another if statement. You know, etc. Don't nest like this. This multiple levels of nesting is generally a bad idea because of what I was saying. You end up with code that's just super complex to read and maintain and debug and all of that stuff. If you have more than 2 levels, right? So here's 1 level and here's 2, right? This actually has 3, 4, 5. If you have more than 2 levels, generally speaking, probably very highly likely that your code sucks and you should rewrite it to where you don't have that many levels of nesting. Okay, so I think that is everything that I'm going to cover with you in this video. So what did we do? We went over the basics of if structures in Kotlin, and we took a look at the different types of relational operators: greater than, less than, greater than or equal to, less than or equal to, not equal to, equal to. And we looked at examples of the 3 logical operators, and, or not. In addition to that, we looked at you know, nesting of these decision structures and, you know, what you can do and why you shouldn't do it too much. So there you go. If you thought the video was useful in some way, please consider giving a thumbs up. If you thought the video sucked, you've got the thumbs down as well. Please consider supporting the channel in various ways. You can join as a subscriber, paid member. You can leave a super thanks and all of that. Leave a comment. And as usual, if you're a student of mine and have any questions, please feel free to email me, stop by my Zoom office hours, or whatever. Okay. So thanks for watching, and we'll see you next time.